Hello folks, my name is Errol Oscar. I am representing Team 9 and today I will be discussing our bio-inspired design concept. So, we all have the same problem when we wake up in the morning, and that is we can't decide what outfit we want to wear. Now, this can turn into a hassle real quick. Wouldn't it be nice if we could just change our outfits whenever, wherever? Well, my team's proposal to this problem is to make an adaptable camouflage fabric that is inspired by cephalopods. Now, there are a few different species of cephalopods, but the one you might be most familiar with is the octopus. And we chose this species for their unique abilities, which you can see here. So what's happening inside the skin of a cephalopod consists of tiny organs known as chromatophores. And these chromatophores are pigment sacs that are very elastic and can contract and expand rapidly on command. Now, depending on the species, they can have multiple colored chromatophores, which then allows them to blend into their environment seamlessly. So, to incorporate this ability into our design, we will use an array of mechanical chromatophores that are layered throughout the fabrics, and they will be controlled by electric signals and sensors that are then controlled by the user. This will allow the material to change its color and texture on command. A common question opposing this design is if these mechanisms can be electrically powered, then why not just use a flexible display with things such as high resolution or colored pixels? Well, these artificial chromatophores are unique because of its ability to change the texture, and the manipulation of the mesh texture significantly increases its ability to create effective camouflage. So how does this relate to our class material? Well, we want our artificial chromatophores to be able to move in such a way that they can expand and contract with ease and without risk to fatigue after long use. The artificial chromatophores require plastic deformation to achieve their purpose of changing the overall color and texture patterns. Therefore, we must ensure we apply only a little force on the chromatophores. That way they always stay in the elastic region, shown here in the green, and remain functional. Additionally, we will need to do a high cycle fatigue analysis on these mechanisms to determine the material's cycle life, since they will be loaded and unloaded millions of times. The goal of the material is to be able to withstand infinite cycles, but realistically, more than a few uses would be ideal. We can see here shown the infinite life is where the region that we want to be in. So as you might have already pieced together, bio-inspired camouflage mainly includes coloring strategies. Now, by learning from nature, lots of researchers have developed a series of adaptive camouflage materials and devices. Since the material can change colors and adapt to the surrounding environment under different temperature and light conditions, this offers a lot of convenience and benefits in many professional fields. For example, some forms of these materials are widely used in military. It is extremely useful in specific areas that require camouflage, such as the desert and rainforests. And this provides great convenience and also, most important, safety for the soldiers in those areas.